Welcome everyone to Ice Glen, Stockbridge's old growth forest and forest gem on many levels. We want to introduce it to you today and take you for a walk. And we've got some interpreters that will help you to understand why we're calling this the gem forest. We hope this is going to be a highlight, and you will like it so much that you will come back and visit and bring others.
My name is Patrick White. I served on the Stockbridge Select Board from 2020 to 2025, and during that time got to know this land behind us known as Ice Glen pretty well. I want to give you a little bit of the cultural history of Ice Glen, starting with the bridge behind us. This is the Memorial Bridge, which was built in the late 1800s to honor Mary Hopkins Goodrich, who founded a local civic improvement organization known as the Laurel Hill Association. The history of Ice Glen actually predates this bridge, though. You know, in sort of pre-colonial times, it was the same geologic gulch that exists today. And I can just imagine when John Sargent arrived, the first missionary in Stockbridge, to found Indian Town in conjunction with Chief Kankapot, that they actually walked the same trails that we were walking today. They weren't the only ones from history to walk these lands. Herman Melville, who wrote the great American classic Moby Dick, used to come down from Pittsfield to walk with his friend Nathaniel Hawthorne, who wrote The Scarlet Letter and In the Berkshires, Tanglewood Tales, and a number of other books. They used to come down specifically to walk through Ice Glen. In fact, when Melville wrote Moby Dick, he included a line, it's actually a reference to this beautiful spot. You'll see that there's a whole lot of great ecological and geologic formations here. We've got what Bob Leverett tells me is the tallest known shagbark hickory in New England, the tallest known hemlock in New England, the third largest volume pine in Massachusetts. So there's a lot of great nature here, but there's also a lot of great history. And so much of Ice Glen is a result of the folks who over literally centuries have worked hard to preserve it. David Dudley Field, for example, donated Ice Glen to the town. All the rock formations you see in Ice Glen that are part of the trail, those hewn steps, were all fabricated by locals and literally dragged, most likely by oxen, up into that ravine. In my time on the Select Board, I had the great honor of being one of the founding members of the Stockbridge Moheakin Commission, which is dedicated to mutual understanding, to empathy, which comes out of understanding, and to actual reconciliation. I'm not going to presume to tell the Moheakin story. I do, however, want to tell the story of these signs that say Watatanik. This was a project of the Stockbridge Moheakin Commission to honor the language of the Moheakin people, and we wrote a dedication last year that I want to read to you now. Watatanik. Translated, it means the land beyond the mountains. What the ancient voices named this place we now know as the Berkshires. It may be hard for some of us to imagine, but for time immemorial, Moheakin was the language of these lands. Beyond this bridge lies an ancient forest, now known as Ice Glen, so old that its same trees were already mighty when Chiefs Kankapot and Umpachini welcomed white settlers with some trepidation 300 years ago. Watatanik. The word encourages us to imagine a time in this place when the forests were stewarded rather than owned. They encourage us to imagine a time in this place when we only took what was needed and gave thanks every day for that which was taken. If these oak and hemlock and pine could talk, they might tell the story of Moheakin and settler walking these same paths, learning each other's words and ways in the newly founded Indian town. They might recount a time when Kankapot and John Sargent together walked these woods. They would perhaps remind us to once again listen to one another, to shine a light in this modern world through a lens of timeless wisdom. Watatanik is but a fragment of the many words of these ancient old-growth woods. If the forest could speak, the stories it might tell, we're honored to take this moment to once again speak this phrase of the common tongue when these trees were young. Many of us hope that, going forward, as our Moheakin friends share with us their timeless wisdom, we will together become better stewards of these rivers, meadows, lakes, and forests of Watatanik, this beautiful land beyond the mountains. Thank you. And I just want to add, there's 40 acres that we're going to focus on today that is old growth forest. And when this town was founded, all of the Berkshires was old growth forest. And I think that we should acknowledge what's been lost and protect what little part of it remains.
My name's Ken Gooch. I am retired from the state of Massachusetts Department of Conservation and Recreation. My job was to oversee pretty much the health of the forest here in Massachusetts. So I was originally contacted through Bob Leverett and Patrick White to take a look at the health conditions of the forest here, because this is a historic forest. And I saw similar things that I had seen in other forests, the two main ones being hemlock woolly adelgid and emerald ash borer, both invasive insects, non-native insects that were affecting the health of the trees. And the trees were dying in this forest. So in behind me here, you have one of the largest in this stand, and the ash trees across New England, across the eastern part of the United States have been infected by the invasive insect emerald ash borer. And it originally came into the state around 2012, 2013, and has spread rapidly through white ash stands. So the insect, what it does is all trees grow on the cambium, the inner bark, xylem phloem, and that inner bark is where everything moves up and down in the tree. And that's how trees stay alive. So they're eating that out. And eventually what ends up happening is it girdles the tree. It cuts off that flow of nutrients and water up and down throughout the tree. And it's very, very quick. They can kill a tree this size in 3 to 4 years. But emerald ash borer, invasive insect, came in on wood packing material from China. When they come here, they haven't evolved in our forests, so they don't bring the things that keep them in check in their native range to our forest. So it takes multi generations for our forest to acclimate to that, to actually build up that resistance. And the only way really to take care of it, to keep it in check, is to treat trees. This is an incredible tree. Super tall. It's got to be 120, 130 feet tall. This is one of the tallest stands of white ash that I've seen in the state. It'd just be a shame to lose these trees. These trees being protected gives them an opportunity for future generations to have that resistance pool built up in the trees. So I just stopped at this small little 3-inch sapling tree, that hemlock, Canadian hemlock, that has pretty good case of hemlock adelgid. So this was not a tree that was treated, only the larger trees were treated. And on the underside of the needles, it looks like little white cotton balls on the underside of the needles. And you can see how thin the tree is. It is slowly being killed by the adelgid. Treatments help to eliminate that insect, which helps the hemlocks to hold their needles, so they need their needles to photosynthesize to feed themselves. The adelgid is a piercing, sucking mouth part, so it is at the base of the needles and it sucks all the juices out of the plant, and eventually the hemlocks drop their needles early, so it can't, again, feed itself. There's also another insect called elongated hemlock scale, which is another non-native invasive insect. That's here, and you have the adelgid here. So when the populations get to this point, it's pretty much a death sentence for the tree, because the two of them working together weaken it so much, they lose their foliage, they can't fight off the native insects and diseases that are out there all the time, which a healthy tree can fight off. When I first came here, I honestly did not think that these hemlocks were going to make it. They were in such bad shape. And if you look at them now, it's just amazing how much they've come back. They've had 2 cycles of treatment, and they just look so much better. From what I can tell, they look like they're holding 3 years worth of needles, which is what you want in a healthy hemlock tree.
One of the enjoyments of being in a forest is understanding whether it's young, mature, old, what trajectory, developmental trajectory is it on? And that's where really understanding a forest begins. So we're here in Ice Glen, which is essentially a mature forest with parts of it old growth. But which parts are mature or slightly young and which are old, and how do we distinguish between the two? So we have a shopping list of characteristics. And oftentimes they're basically simple to understand, but hard to put into practice once you're in the field. So we're in the field. So what are we looking at here? Well, if we look around us, the dominant tree that we see are these large, mature white pines. A lot of people think this is old growth. It isn't. It's a mature forest. It is not old growth. And how would I know that? Well, because in earlier times, this would have been Moheakin land. And there's a good chance it would have been partially cleared and later on cleared probably by colonists or colonials. And what grows up in fields in our part of the Northeast? Often white pines. They come in dense stands. And then they begin to thin out. But when we see these trees here, this is a mature stand of white pines, but it's not old. But that doesn't mean that every tree in here is even aged, even though these white pines grow up pretty much as a crop or a cohort, as the term is. But if we look in here, we see a small tree, a young red maple. Well, if we look behind us, we would see a black birch that's kind of intermediate age, 60 years old, 70 maybe. Well, what about these pines? Well, they're probably in the 120 to 150 year age range. So as I put out numbers like that, it's easy to begin to at least classify forests age-wise by the age of the dominant canopy trees. And somewhere around 50 and 60 years, ecologists and foresters can probably get together and say, younger, that and younger, we'll call a young forest. And with it goes the characteristics of young forests, namely younger trees. Then comes a stage of about 50 to 60 on up to maybe 150 years in a forest like this. And we would commonly think of that as the mature period of the forest. But it so happens that 150 years is about middle age for a lot of the species that we see in here. So we've got the term 150 and up as old forest. Maybe we say old growth. And then we've got really old. We've got it up there in 250 years and beyond when the trees are reaching their maximum lifespans. And that's what we see in the center of the glen. A big part of the transition between mature forest and old growth really happens on the ground or under the ground. The under the ground part is the complex relationships of fungi that connect to the roots of the trees, and they connect actually tree to tree, and it's an underground city. And we really didn't know much about that in decades past. Well, certainly a century past we didn't. But now we know that old growth underground is as important a part of the definition of an old growth forest as what's above ground. Well, look at the actual forest floor. It's pretty level or smooth going up. If this were an old forest, it would be very uneven. We moved up the trail and entered really an area that's hard to define, but it's older than what we were seeing at the lower part of the trail. And these large overstory white pines are moving up into the past 150-year age range. And we're seeing other species coming in. For example, hemlock, eastern hemlock. We see that. We'll see maples coming in, sugar maples. And so the forest is starting to go through a period in which the large overstory pines are thinning out. They didn't reseed. Once they created a closed canopy, new white pines did not seed on the forest floor. Then come blowdowns from whatever source. And then what happens is you get gaps, light gets to the forest floor, and other species start to seed in, but not the white pines. So now you have a beginning of a change of forest type. It's no longer a pure white pine stand. In addition, some of the big pines are going to blow over. And when they blow over, they create a big hole in the ground. It's a big pit. And where the roots are turned up, that'll be a mound. And as that over time erodes down, it becomes undulating, pits and mounds. And then we start to see mosses and lichens and liverworts in general more frequently. Logs that were just bare logs start to be covered by moss, and the forest takes on a whole different look. This is what we basically start to see in this part of Ice Glen. Further up, it gets even older. So in a way, starting from the railroad tracks, we're right across them, starting at the edge of the forest and going all the way to the glen, we go back through a period of from about probably 70, 80 years at the youngest, and then in the glen, up well over 200 and sometimes over 250 and probably some over 350.
Here we are at the northern entrance of the ravine of Ice Glen in an area where the forest is much different from what we've experienced on our way up the hill. We're in what many people would refer to as old growth. So one of the differences that we see between here and lower down on the slope is the species composition of the forest. Down lower, we see a lot of overstory eastern white pines, but up here, they're virtually non-existent. The canopy is dominated by eastern hemlock, sugar maple, yellow birch, American beech, as well as white ash. And many of these species, particularly American beech and eastern hemlock, are our most shade-tolerant species, and so you would expect to find these in an old-growth forest where they're coming up underneath the shade of the existing canopy trees. In addition to the difference in species composition is what we see on the ground. One example is the undulating forest floor that's a product of pit and mound microtopography, which is a result of mature trees blowing over and pulling up the soil with their root ball. And as they decompose, that root ball becomes a mound of soil right next to the hole that was excavated when the tree fell. We expect to see that in old-growth forests. Another result of the death of trees is what we call coarse woody debris, which basically means large pieces of wood in decay on the forest floor, which would take the form of either large limbs or entire tree trunks. And when an entire tree trunk falls and begins to decompose, it can turn into what we refer to as a nurse log, which is a log in a stage of decay, often covered with mosses and other small plants, that is able to provide a nursery for young trees. Another feature of this old-growth forest that we also saw in the slightly less mature area further down the slope is gaps in the canopy. And what happens is a tree will die and fall over, and where that tree once intercepted the sunlight, the sun is now able to flood down to the forest floor and promote the growth of various forms of plant life, among others, new trees that can take advantage of that new gap in the canopy. Another feature of old-growth forest is its moisture-retaining capacity, and we see this in various forms. Mosses are very abundant in these old-growth forests. We see them on tree trunks, on rocks, basically anywhere that a moss can take hold, it will. Another way in which moisture is retained in old growth forests is in these nurse logs. And that's a reason why they're able to promote small trees growing on top, because even in dry summer weather, they still retain moisture in that rotten wood.
For me, one of the most enjoyable parts of being out in a forest setting is to be able to distinguish trees by age. And that, of course, if we want to know how old a tree is, we have to actually take a core out of it and count rings. But you can determine or come pretty close to figuring out whether a tree is, well, certainly young, that's obvious, mature or middle-aged or old or very old, by analyzing the characteristics of the tree. And I'm going to start out with this hemlock here, which is an old tree. It's probably well above 200 years in age. It could be 250. But why did I say that? What do I see that would suggest that this tree is in that age range? Well, as trees age, their bark thickens. And depending on the kind of tree it is, it might have scales or it might have ridges and furrows. In the case of hemlock, it's the ridges and the furrows in between. The furrows will get deeper, the ridges will be more prominent as the tree ages. And another thing is that the tree will pick up, sometimes it's lichens, mosses and whatnot, that will give discoloration to the bark color. The bark itself will also, there will be an oxidation process going on, so the bark will sort of bleach out, so to speak. And so there will be a color change as the tree gets older. So you can start to recognize age in trees by the texture of the bark and also by the color of the bark. When the tree gets much older, this outer bark is dead, so it'll start flaking off, and then you'll get bald patches. And so you can begin to recognize trees that are really old by balding spots. As the tree ages also, its shape will change, its dimensions will change. It will get much more prominent root flares. And as you go up the trunk, you'll see often a gradual taper, but once you get up to where the tree starts to have limbs jutting outward, those proportions will change. An older tree will have noticeably larger limbs against the main trunk than a younger one. Once you get into the crown of the tree, if it's a young tree, that crown is often symmetrical and usually comes to a fairly noticeable top, oftentimes very pointed in the case of hemlocks and whatnot. But as time goes on and the tree survives winds, ice, snow, droughts, what will happen is that the crown will break up and regrow and break up and regrow and become much more asymmetrical. So we start to recognize, and in fact, often the crowns will flatten out at the top. So really old hemlocks cease to have an upward growing leader that is clearly, distinctly the top of the tree. So you got an asymmetrical crown in great age, you get symmetry in youth. Other characteristics are going to be individual to the species. So if we look at some trees when they're really young, for example, red maple, its young bark will be smooth and gray. Sometimes people mistake young red maples for beeches. But as it gets older, the bark becomes darker, it will be brownish, and it will have strips of bark that hang down in a vertical direction and flare out oftentimes at the bottom. On the other hand, a tree like an American beech has smooth gray bark when it's young and kind of smooth, fairly smooth, gray bark when it's old, of course, unless it develops diseases or something like that. You have to take each species individually. But when you do that and you practice at it, the forest becomes knowable to you.
I'm Ben Nickley. Right now I'm standing next to a very old eastern hemlock tree. Trees that have been in this ravine for hundreds of years. And these trees are beautiful and incredibly rare to find, trees that are so old in the eastern United States, where many of our forests have been cut time and time again over the centuries. And so this is truly an ecologically special place, and also crucial for birds that I love and that I study. There are about 8 species of birds that depend on northern type forests like this, white pine, hemlock forest types. And these forests are fairly limited within the state, and so these bird populations that depend on these forests are also somewhat restricted. So the species that I want to talk about are birds that have their core populations primarily north of us in the boreal forest of Canada. So I'll start with Blackburnian warbler, which is one of the most spectacular little birds that you can find anywhere in the eastern United States. It's a little wood warbler in a tropical family of birds that is a long distance migrant. It comes straight from South America in the spring all the way up to Massachusetts or even further north to Canada to breed. So Blackburnian warbler is dependent on hemlocks. So you're only going to find them in forest types that have a nice mature hemlock component, and there is no better place for them in this part of the Berkshires than Ice Glen, because Ice Glen has old, massive hemlock trees. Another long-distance migratory warbler that you can find in this forest is black-throated green warbler, which is another truly beautiful bird, and they also are very dependent on hemlock trees. There are other species of birds that are also quite common in Ice Glen that are shorter distance migrants that overwinter in the southeastern United States and parts of Mexico for some of them. Truly one of my all-time favorites is the winter wren, which is a tiny little bird. You might confuse it for a mouse because they run around on the forest floor. They're this rich dark brown, and they're just little tiny guys with a cocked stubby tail. And while some might think of them as more nondescript than the vibrant and brilliantly plumaged Blackburnian warbler, what winter wren has above many other species is a extremely complex and long, beautifully musical song that they will just burst forth with. So when you come to Ice Glen in the spring, you will be serenaded by winter wrens. You also have red-breasted nuthatch, which is a cool, cute little bird with a really funny kind of comical sort of call. And they are in Ice Glen and surrounding areas where there is a good, strong conifer component. And nuthatches are cavity nesting species, and as such, they need suitable nest structures, dead trees, dead limbs that have rotted, so that they can excavate out their nest cavity. And forests like this that have been left alone and have trees that have actually aged over the centuries have a lot of this resource for nuthatches and woodpeckers and other avifauna. Another species that's quite common here in Ice Glen is the hermit thrush, which is a little brown bird with another beautiful song. Unlike most of our other songbirds, which are primarily singing early morning hours, hermit thrush will serenade this forest with its beautiful song late afternoon. So that's a wonderful time to come and walk through these trails. You also have brown creeper in here, which is a bird that loves big diameter trees like these hemlocks that have deeply furrowed bark. Brown creepers are really cool little cryptic birds. They actually look like a piece of tree bark that is defying gravity by just moving up the trunk of the tree. So they really blend in extremely well. And creepers are really hard to see because they're very small, but you can often hear them making their high-pitched C call. So if you hear that, you want to look up. Another fantastic bird of Ice Glen is the dark-eyed junco, which for most people in the eastern United States, that's a snowbird, a bird that people typically see in the winter months, because most dark-eyed juncos breed well north of us. But because the forest is a northern forest type in this cool, protected and sheltered ravine, you have birds that are northern breeders seeking refuge. It's a sort of a climate refuge for these species, and they breed here. And it's one of only a few places actually where you're going to find them at lower elevations in the county. So for people seeking to find birds or hear birds, listen to them and appreciate them, really all you have to do is walk down the trail and walk quietly and look and listen and be mindful and observant. In the spring and early summer, birds in this ravine are just going to be bursting with song, and they're going to be singing their species-specific song. So they tell you not only where they are, but who they are. So definitely pay attention and listen.
Here at the southern end of the Ice Glen Trail, we get a really nice sense of the geomorphology or landscape shape of this valley. It's extremely steep on both sides, it's very narrow, and it's distinctly V-shaped. The sides are covered in piles of extremely large boulders, some of which are the size of small houses and which have tumbled down from higher up on the hillside. This is a really unusual type of landform, particularly in this area, and it has its origins at the end of the last ice age. As ice sheets were retreating, valleys that were partially blocked with piles of dirt and ice left behind by the glaciers filled up with water. They formed large, what we call glacial lakes, and these were very common throughout northeastern North America. In the Stockbridge area, we refer to Glacial Lake Housatonic. Long vanished, the Stockbridge Bowl is the last tiny remnant of this former very large lake. The lake persisted probably for a few thousand years, and it found ways to exit to lower ground and to the ocean where there were dips in the topography. In some cases, the barriers to the lakes gave way quite suddenly, generating catastrophic floodwaters that came out through what we refer to as glacial spillways. And Ice Glen is one of those spillways. The reason it is so deep and narrow is because it was carved by outrushing waters, probably carrying large boulders that crashed into the sides of the hill and cut it down quite rapidly as that glacial lake began to empty. As we work our way up along the trail, we start to climb through the giant boulders that have fallen into the center of this glacial spillway. They do not appear to have been moved very far from where they were detached, so all of them are quite angular and large, meaning that they fell down the mountainside as opposed to being transported here by glacial flow, for example. And they probably represent the oversteepening of the valley walls by the outburst floods as the lake was emptying.
The forest here at Ice Glen offers us a prime example of the advanced stages of a process called ecological succession, in which a once sterile environment is transformed into a dynamic ecosystem brimming with life. The boulders here in the ravine are something of a microcosm of the broader environment in which they are situated, in the way that they've become populated with plant communities on their exposed surfaces. So if we imagine at the end of the last ice age, when glacial Lake Housatonic was receding and the ravine that we now call Ice Glen was transforming from an aquatic environment into a terrestrial environment, the first colonizers on these rocky surfaces would have been lichens and mosses that only require a modicum of moisture to really take hold and establish themselves. Now, if you imagine the passage of time, the inevitable death and decomposition of these small organisms, and the accumulation of additional organic material coming in from the wind and gravity, a very thin layer of soil began to form on the exposed, mostly the top surfaces of these boulders. And in this thin layer of soil, slightly larger plants could take hold, such as ferns, grasses, herbs, and such. And so, with yet more time, more decomposition, more accumulation of organic material, that soil layer thickened to support even larger plants, like shrubs and small trees. And in some cases, we even find fully mature trees perched on top of these rocks with their roots extending down into the ground. There are certain species that prefer the top surfaces because of the amount of sunlight they receive and their ability to withstand desiccation that comes from that sunlight. And then other species prefer the side surfaces like this, where it's a bit shaded. They receive water runoff, whatever runs off the top, they receive here. A boulder like this has many different environmental conditions over its surface that different plants can colonize and establish themselves. And it's scenes like this, boulders like this, that are covered in plants of all kinds and sizes that we expect to find in our old-growth forests here in the northeastern US. Now, as you approach the Ice Glen ravine from the north, as you cross the railroad tracks and approach the ravine, you'll notice that the forest that you're walking through is different, and the boulders in that forest are comparatively bare. And the reason for that is simple. That forest is younger. It's at an earlier stage of ecological succession, and it was disturbed in the recent past. And that disturbance would have disrupted the environmental conditions that make plant communities like this possible, namely consistent moisture, shading from direct sunlight, and protection from the wind.
Northwestern Massachusetts has a very ancient geologic history, and in this area that spans from about 1 billion years to about 500 million years ago. The rocks in this area were eroded from long gone mountain belts. The mountain belts were about 1 billion years old, and imagine those mountains eroding and shedding sand and mud that built up in rivers, along coasts, and in the shallow offshore area of what was probably a near tropical environment at the time. This rock is made up of lots and lots of tiny grains of quartz and clay that indicate that it was originally a sort of a muddy sand, probably deposited near a coastline. And if you look at these rocks, you can see that there is layering within them that relates to compositional variation in those sediments as they were built up and stacked over time. But about 500 million years ago, these rocks were squeezed, heated up, pressurized, and deformed as a continental collision occurred in the area that we now consider to be eastern North America. And these former sediments became metamorphic rocks that were uplifted to become the cores of new mountains. And we can tell that process by looking at internal structures of the rock, looking at folds and faults, and the way in which minerals have been recrystallized. This may look like simply a rough gray rock surface, and it's difficult to get close enough with the naked eye to see. But in fact, a lot of these little roughnesses are individual former sand grains. And you can see that this is not completely homogeneous, but there is an internal structure to it. Some of this structure is the original compositional layering. Some of it relates to the recrystallization of minerals during the metamorphism and structural deformation of these rocks. These rocks, because the minerals within them are resistant to weathering and erosion, quartz, for example, is a very tough mineral, tend to form high places and to form outcrops that we can come up and look at easily. Another very common rock in this area is marble, which is metamorphosed limestone. Limestone is deposited in shallow, warm oceans, and then when it becomes pressurized and metamorphosed, it changes to marble. And the characteristic marbles of this area, the Stockbridge marble, which, for example, in Stockbridge itself, you will see in the water features and fountains in the town. In the landscape, that is a rock that erodes very, very easily. Rainwater can dissolve it. And so the valleys in this area tend to be underlain by marble, whereas the hills and high places expose these more resistant sediments.
For people to really appreciate places like Ice Glen, they need to experience them. And so having trails in places like this is really important because it provides the possibility for people to get out and in this kind of an environment so that they can really experience it. We don't care about what we don't know. You have to have some kind of understanding and appreciation for something before it matters to you and it means something to you. And so to help people to appreciate places like Ice Glen, it's as simple as bringing them out here. It would be hard, I would think, for anyone to walk this beautiful trail amongst the craggy rocks and the ancient hemlocks, even with no knowledge of forest ecology or anything like that, and still not feel something and not be impressed by the beauty of this special place. Places like this can be, living classrooms and special places to bring people out and, to teach people, what a hemlock tree looks like or what a pileated woodpecker sounds like, and really initiate them into exploring the natural world and appreciating it. Because today, we spend a lot of time on our phones. Me too, looking at screens. And I think now more than ever, it's important to get outside and appreciate the complexity of what's around. It could be, a teeming brook. It could be a sunspot on the ferns. The outdoors, it's a dynamic place and one that you can't help but appreciate once you experience it.